In section 8.6, we're solving equations with radicals. Our objectives are to solve radical equations using the power rule, solve equations that require additional steps, solve radical equations with indexes greater than 2, and use the power rule to solve a formula for a specified variable. The power rule for solving equations with radicals. If both sides of an equation are raised to the same power, all solutions of the original equation are also solutions of the new equation. Solutions that do not satisfy the original equation are called extraneous solutions. They must be discarded. Here's a radical equation. We have the square root of 5x minus 6 equals 7. The way we can isolate the variable here by solving for x is to raise both sides to the same power. So the inverse of the square root is the squared power. So we can square the left side of the equation as long as we can square the right side of the equation. And since the squared power and the square root are inverses, they will drop out, they'll eliminate, and we end up with 5x minus 6 on the left side. So the square root and the squared power are inverses, and they'll cancel each other out to get 5x minus 6 on the left side, and on the right side, 7 squared, we get 49. Now we can solve this equation for x by adding 6 to both sides of the equation. And then we get 5x is equal to 55. And then we can divide both sides by 5 so that we get x is equal to 11. So the solution to this new equation, after raising both sides to the second power, we end up with a new equation, 5x minus 6 equals 49. And that solution is x equals 11. We do need to make sure this solution checks in the original problem. So in our check step, we're letting x equal 11 in the original equation. So this is going to be 5 times 11 minus 6 under the radical on the left side, and we want to make sure that that's equal to 7. When we simplify, we get the square root of 55 minus 6, and the square root of 55 minus 6 is the square root of 49, which does equal 7. So our answer to this radical equation is x equals 11. Solve an equation with radicals. Our step 1 is to isolate the radical. Make sure that one radical term is alone on one side of the equation. Step number 2, apply the power rule. Raise both sides of the equation to a power that is the same as the index of the radical. Step number 3 is to solve the resulting equation. If it still contains a radical, repeat steps 1 and 2. And step number 4, very important step, is to check all potential solutions in the original equation. Here we have another radical equation, the square root of 2x minus 9 plus 1 equals 0. Our first step is to isolate the radical. Get the radical term by itself on one side of the equation. We can do that by subtracting 1 from both sides. And when we subtract 1, we get on the left side the square root of 2x minus 9 equals negative 1. Now we raise both sides to the second power because the square root and the second power are inverses. So if we raise the left side of the equation to the second power, we also want to raise the right side of the equation to the second power. The square root and the squared power are inverses, so the left side is simplified to 2x minus 9, and the right side is positive 1. Now we can solve this equation for x by adding 9 to both sides. And then we get 2x is equal to 10. And then divide both sides by 2. And we get x is equal to 5. We do want to check to make sure that this solution works out in the original equation. So again, that check step is important. Our check is to write the square root of 2 times 5 minus 9 plus 1. Does that equal 0? So we get the square root of 2 times 5 minus 9, that is 10 minus 9 plus 1, and then the square root of 1 plus 1. 1 plus 1 does not equal 0. So even though we were able to algebraically get an answer of x equals 5, this is an extraneous solution. And we must eliminate that as an option. So this equation has no real solution. All right, let's solve this radical equation. We do have the radical isolated by itself on the left side. So to do the inverse of take the square root, we want to use the power rule. We want to raise both sides to the second power. And the square root and the squared power are inverses, so the left side of the equation becomes 9 minus x. Now the right side of the equation is x plus 3, the whole quantity squared. Think of this as x plus 3 times x plus 3, and don't forget to use the FOIL step, multiplying the first, the outer, and the inner, and the last. So when you do that, you get x squared plus 3x plus 3x plus 9. That's your first, outer, inner, last on the right side. Now this is a quadratic equation. I can tell that it's a quadratic equation because I have this highest power of 2. So we solve quadratic equations either by factoring or by using the quadratic formula. In both cases, we want to get the quadratic equation in standard form. And again, standard form is where you have ax squared plus bx plus c equals 0. So we need to rearrange the terms here. On the left side, we'll leave 9 minus x. On the right side, we'll combine like terms. We have x squared, the middle two terms, the outer and the inner, will give us 6x plus 9. Now I'm going to make sure that one side of this quadratic equation is equal to 0. I do that by adding x to both sides, as well as subtracting 9 from both sides. And you're combining like terms here. So on the left side, we get 0. On the right side, we get x squared. The 6x and the plus x that we added to both sides, we can combine those. Those are like terms to get plus 7x. And the plus 9 and the minus 9 will cancel out to 0. Now we can complete this by factoring. The greatest common factor of the two terms is x. So we can write this as 0 equals x, the greatest common factor. And what we have left is x plus 7. Using the zero factor property, we can set each of those factors equal to 0. The first factor being x. If 0 is equal to the first factor times the second factor, either the first factor is equal to 0, x equals 0 is a possible solution, as well as x plus 7 equal to 0. And by subtracting 7 from both sides, we get x equals negative 7 as another possible solution. We do need to check both of these to make sure they work in the original equation before we did the power rule for solving equations. So our check here, check each one individually. Let's start off with x equals 0. On the left side, if you put in 0, you get the square root of 9 minus 0. Does that equal the right side, which is 0 plus 3? And on the left side, square root of 9 minus 0 is the square root of 9, which is 3. And on the right side, we get 3. So 0 is a solution to this radical equation. Let's check to see if x equals negative 7 is a solution to the radical equation. So on the left side, we get 9 minus x, which is negative 7. We want to make sure that that is equal to the right side, x plus 3, or negative 7 plus 3. On the left side, we get the square root of 16, which is 4. And on the right side, we get negative 7 plus 3, which is negative 4. So although we algebraically got the answer of x equals negative 7, we need to eliminate that as a possibility because it is an extraneous solution. So our only solution to the equation is x equals 0. We can write our answer as x equals 0, or we could also write this using set notation. So the solution set is 0. Caution on the middle term. When a radical equation requires squaring a binomial, as in the last example, remember to include the middle term. X plus 3, the entire quantity squared. If you work it out using the FOIL method, that middle term is 6x. I've seen too many students make a mistake of just sharing the power. Don't make that mistake. Really take your time to write x plus 3, the whole quantity squared, as x plus 3 times x plus 3, and use the FOIL process to make sure you have that middle term. Let's solve this equation. We have the square root of the quantity x squared minus 8x plus 3 on the left and x minus 5 on the right. The radical is already solved, isolated on the left side, so we can use the power rule. Again, the power rule, we're going to raise both sides to that power, In this case, it's the square root. We raise it to the second power. You want to make sure you raise both sides to the second power. The square root sign and the squared power are inverses, so they'll cancel out. And on the left side, we get x squared minus 8x plus 3. On the right side, we have x minus 5, the entire quantity squared. So think of this as x minus 5 times the quantity x minus 5. And use the FOIL process. For the first x times x, you get x squared. The outer, x times negative 5 minus 5x. The inner, minus 5x. And the last is plus 25. Now we have a quadratic equation. We do have the power of 2, the greatest exponent of 2. So we can solve this. We can combine like terms on each side of the equation. The left side is as simple as you can write it. The right side, you can combine the middle terms to get minus 10x as your middle term. Now we can add and subtract on both sides of the equation. We can subtract x squared from both sides of the equation and we end up with a linear equation. We could, in addition, we can add 10x to both sides. And let's see what this works out to be. The x squared minus x squared are opposites. The minus 8x and the plus 10x is 2x. You can bring down the plus 3. And the x squared minus x squared on the right side are opposites. The minus 10x and the plus 10x on the right side are opposites. So we get 25. Now we can subtract 3 from both sides and get 2x is equal to 22. Now we can divide both sides by 2 and get our final answer of x is equal to 11. We do need to check to make sure that this works in the original equation. So on the left side we have x squared minus 8x plus 3, the square root of that quantity. So this is 11 squared minus 8 times 11 plus 3. This can be simplified. 11 squared is 121 minus 88 plus 3. And let's simplify this to the square root of 36 on the left side, and we want to make sure that is equal to x minus 5 on the right, which is 11 minus 5, and 11 minus 5 is 6. The square root of 36 is 6, so our answer checks. So we can write our answer as x equals 11, or we can use a set notation, writing 11 inside the squiggly brackets. All right, in this case, instead of square roots, we have cubed roots. We want to solve the cubed root of the quantity 3x minus 2 equals the cubed root of the quantity 2x plus 6. Instead of squaring both sides, we're going to raise both sides to the power that is the inverse of the cubed root. And the power that we're going to use is the power of 3. Since those are inverses, we can simplify this equation. The cubed root and the cubed power are inverses. So the left side becomes 3x minus 2. On the right side, the cubed root, the index of 3, and the cubed power, the power of 3, are inverses. So the right side can be simplified to 2x plus 6. Now we can solve this equation by subtracting 2x from both sides. And we can add 2 to both sides in the same step, or you can break it up into 2 steps there. And we get 3x minus 2x, which is x. The minus 2 and the plus 2 are opposites. And on the right side, we have 2x minus 2x opposites, and 6 plus 2 is 8. So it looks like x equals 8 is the solution to this equation. We do want to check to make sure that this is indeed a solution to the original equation. The original equation was the cubed root of 3x minus 2, or 3 times 8 minus 2. So that simplifies to the cubed root of 24 minus 2, or the cubed root of 22 on the left side. Let's see what the right side of the equation gives us. The cubed root of 2x plus 6, or 2 times 8 plus 6, is that equal to the cubed root of 16 plus 6? And it is indeed the same. On the left side and the right side is the cubed root of 22. So this is a solution to our original radical equation, and we can write our answer as x equals 8, as well as using the set notation that the solution is x equals 8.